Hello viewers and welcome to the HE class. So today we are going to learn about to show that pressure is given by H rho G, to show that pressure equals H rho G. To show that pressure is given by H rho G. So we are going to consider a diagram here. This one is a block of wood resting on the table. So this one is a block of wood resting on a table, and the dimensions are length, width, and height. Those are the dimensions. Then it has a mass M. The mass of this body is given by M. So it is right to say from definition, pressure is given by force acting perpendicularly per unit area. So from the definition, pressure is given by force acting perpendicularly per unit area. Then it is important we ask ourselves, which force is acting here? And the force acting is the weight of this body. So in other words, but the force acting is the weight of the body, which is given by mg. So that means pressure is equals mg divided by area, the weight of the body resting on the ground. So in this case, since we have length, width, and height, which can give us the volume, we know that but mass of the body is given by rho v. That is density times volume. Mass is normally given by density times volume, and that means pressure here becomes rho times v times g, where rho and v gives you mass divided by area. So that is we have replaced the value of mass from our equation. Then we also know that volume is given by cross-section area times height. We know volume of this shape here will be given by length times width times height, but we know length times width is the area, the cross-section area. So in other words, volume of this body is given by cross-section area times height. In other words, length times width times height, whereby length times width gives you the length times width gives you the area. So on replacing this in our equation, we now have pressure is equals, we start with rho times, where we have volume, we have cross-section area times height, so it will be area times height, that is our volume. Then we have times g divided by area, times g divided by area. So at that point you realize that we have area in the denominator and also in the numerator, so we can cancel by area, and that means pressure is given by rho times h times g. When you multiply, you realize that there is no order, because you can say 2 times 3 is the same as 3 times 2. So that simply implies that pressure can be given by h rho g, whereby we are saying pressure is given by height times density times G.